This Common Core standard requires students to perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. This task requires students to make conjectures and predictions to discover how numbers are multiplied and divided in scientific notation. It's divided into two parts. Section 1 involves answers that are arrived at in correct scientific notation, and Part 2 requires students to adjust coefficients to put numbers in correct scientific notation. In this task, the students will use prior knowledge of laws of exponents and scientific notation to make real-world comparisons of very large and small numbers that would be too difficult to do with numbers when they're written in standard form. Several parts of the task require students to explain their reasoning or make conjectures about what will happen when they perform the operations with the scientific notation numbers. Another part requires students to create their own problems to solve, as well as to solve problems created by their classmates. This initial phase is completed independently and then shifts to student working in pairs or groups to work on their created problems. This lesson is completed in one 55-minute class period. How I plan to teach this task is I always begin my lessons with a quick whiteboard review. For this lesson, I presented students with numbers which required them to convert between scientific notation and standard form and vice versa. This strategy really invoked the prior knowledge that we had earlier in this unit that will also be used to solve the problems today. As a hook, I asked the students, if I give them some measurements, could they figure out which distance was further, LaGrange to Atlanta or LaGrange to Columbus? Most of them knew that Atlanta was further. I then asked them, could they tell me how many times greater the distance to Atlanta was than the distance to Columbus was? Most of them still said they could, because all they had to do was really subtract the two numbers. This is a common misconception when dividing in scientific notation, because subtraction would only reveal how much further the distance was, not how many times greater the distance was. To find this answer, they would have to divide the two distances. So I told them just hold on to that thought until later on in the class period. I then gave the students the task sheet and asked them to begin working to see if they could devise a rule or procedure we could use when dividing numbers written in scientific notation. Once we arrived at a working conjecture, I had them create a problem with two numbers in standard form, then give that problem to their partner and have their partner solve them. I closely monitored this part because this is where the students wanted to simply just divide the numbers as they were written in standard form rather than converting the numbers into scientific notation and then dividing. What they were doing was they were taking the numbers and just dividing them in standard form. Once they got the answer, then they would convert the answer to scientific notation, which was really defeating the whole purpose of what we were trying to do. Then the students began to work in pairs. I kind of put them together to complete the activity, measuring distances in the solar system based on numbers that I give them, and also comparing money revenue from a list of movies that were popular in the previous couple of years. What they had to do with these was convert each one of the numbers to scientific notation, and then they would have to either multiply to find the total revenue arrived at, or divide to find how much which one had more money. It was different ways they had to work through this. So they had to actually talk about what they had to do. They had to figure out, do I need to multiply? Do I need to divide? Which one do I do first? What do I need to do last? So as I did this, I just kind of walked around the room and monitored the student work during this part of the task. And most of them stayed pretty well on task. A couple of them I had to redirect, which is nothing normal, nothing out of the norm when you're doing group work. After I did the lesson, I kind of reminded the students, I said, all right, let's go back to the question that we posed earlier. how many times greater is the distance to Atlanta from LaGrange than to Columbus from LaGrange? Most of them knew now, said, oh, okay, now we must divide to find that answer. And then we need to convert it to scientific notation or adjust the coefficient to make sure that it's in correct scientific notation. So I was kind of glad they figured that out on their own. Part two of the graphic organizer, the ticket out the door, I kind of presented them with a little different problem because they haven't had one of these yet, where one was in scientific notation and the other was in standard form. So this one kind of really threw them for a loop for a few minutes. I watched them kind of struggle with it. Most of them were wanting to convert from scientific to standard, which works well when the number is kind of small, but when we're dealing with numbers like numbers that would be in outer space, the distance between the planets, they quickly realized that wasn't going to work, and they said, well, we can just convert this over. So I kind of used that as a guide once I got my data back from that for the next day to divide my groups up for the next day's activity. So it was a pretty good ticket out the door, and it kind of really let me know what they knew, what they didn't know, because it kind of combined everything we did plus something that we didn't do that we were actually going to touch on in the next lesson. How they learned. The students they worked well in pairs. Like I said, initial phase, they worked by themselves. I wanted everybody to work by themselves to start with to arrive at a conjecture to figure out what they needed to do to solve these problems. A lot of times you'll get a stronger student that wants to take over, and the other student will let them work and just basically accept their answer. So what I did was I said, you work by yourself first, and then we will talk about it in a minute. Once they did that, then we put them in pairs. I put them in pairs and had them work together. So they did. It kind of worked out pretty good because then they could actually check their work with each other on their problems that they created together. The second part was they had to really apply what they learned. I mean, they took it and applied it to the space, the distances in space, the movie revenue, and then they also had to do it to their student peer created problems. So there was multiple ways that they had to figure out multiple scenarios. I mean, I know this was basically at this point maybe more or less doing procedures without connections, but they still had to do some work, and they did have to do some explaining, and they did create. One way they learned too is I did it very sparingly, but my monitoring, but the questioning, if I saw something that were really struggling, I let them struggle to a point, and then I said, all right, well, what if you thought about this? Have you tried this or tried just kind of leading them just a little bit, just enough to get where they needed to be. And then finally, again, as I said, they created their own scientific notation problems and created the one by their partner. So they had to analyze, they had to create, they had to apply. So there was a little bit of higher learning involved in this lesson. One thing I figured out, changes to the task that I would make, I would change the task sheet by removing the answers the students would get after dividing. The answer was actually written in correct scientific notation, and they had to actually multiply the numbers in standard form or divide the numbers in standard form first. And a lot of them would actually take that and they used that answer as more as a guide, really more than I wanted them to. The basic concept and underlying theme really with multiplying and dividing scientific notation is determine what really do we need to do with the exponents, really more than the coefficients. Prior experiences the students had with multiplying and dividing exponents, having the same base, should have really guided their study, guided them in the right direction of what to do with the exponents. However, I guess they really must have forgotten, or I really don't know, because we just had covered this concept in the previous unit. They didn't make the connection that the concept was still the same, even though we were doing it in scientific notation. And they were still a little confused as why we were adding the exponents when we were multiplying and why we were subtracting the exponents when we were dividing. So it kind of got me made me worry a little bit. Do I need to go back and review the laws of exponents with them to kind of refresh before we move forward? So And again, to alleviate some of this confusion, I asked them questions that would really jog their memory to what we did in Unit 2. What did we do earlier? What if we were multiplying x to the second times x to the fourth? How many x's total did we have? So they kind of really got it then. So I kind of guided them a little bit, really more than I wanted to. So I'll work on that more next time. The next part is really allowing more time to complete the task. The task was divided into two parts. Some of them got it real quickly, especially the first part. The second part was where they had to adjust the coefficients. They even got that pretty quick too. So what I would do is and when they were done, they would kind of sit there and get kind of bored, and I could tell it was kind of dragging on. So for those students who got through earlier, what it really made me do is kind of move forward before I really wanted to, before everybody really arrived at the answer on their own. So I basically had one or two students say, what did you do? Tell us what you did. Tell us your strategy for solving the problem. So it really didn't allow all of them to complete the task as I wanted them to. So that's one thing that I would do. Next time what I'll do is I'll have for those quick finishers, I'll have them a few problems to do, or maybe put them in little pairs just for a few minutes and let them create some more problems, because the more problems they can create, the more skilled they are at mastering the concept. And then the last thing I would do was allow more pairs to present their problems. I let some present, not many, basically because of the time. But what I like to do is as I use whiteboards in my class as a review technique all the time. And what I really like to do next year is next time I do this is to let more students present their problems that they created, and let the class solve their problems on their whiteboards, and just do a little quick rotating and let each one of the groups present, or each pair present, and let the class solve the problem. And let's talk about, is there any misconceptions? Can I clean up any misconceptions, or do they still have any misconceptions? So that would be one of the major changes I would take. The planned cognitive demands of this task, really parts 1 and 2 of the task were procedures with connections, because the students were forced to make conjectures. They had to come up with their own rules. Even though they were guided slightly, they pretty much were on their own to figure out, which is really why it's not doing math, because they were guided to a degree, but it still makes it with connections. They also had to test that conjecture. Did it work? Did it not work? Do I need to adjust this? Do I need to figure out why my exponents are not coming out right? And finally, they had to justify their answers. They had to explain to me, and they had to explain to their classmates why they chose what they did, especially when they chose to when they solved their problems. How did they solve their partner's problems? Part 3 was the scenario where the distance in the planets and the movie theater revenue. Some of that would be procedures without connections. Excuse me, I have without and without on here again, but it should be with and without, because part of it is still they're doing the same thing over and over again, which will make it without connections, but still they're having to explain why they did what they did, justify why they did it. They're still creating new problems. They are taking problems and converting stuff back and forth. Stuff that they don't have to do. It's not just here it is. They have to figure out what goes where, how do we do it? And still they had to explain. They had to come up with their own explanations. They could not, I just would not accept just because it's this way. They had to tell me why. The resulting cognitive demands, the vast majority of the task was maintained at procedures with connections, because students had to constantly make those conjectures. They had to create their own problems. They analyzed their work as well as the work of a classmate, and they had to explain their thought process both in writing and verbally. So they had to communicate it in multiple ways. The last part was students had kind of a little difficulty figuring out what to do when adjusting the coefficients. As far as they were initially confused as to when they should add or subtract from the exponent. But most of them finally figured out what to do is to look back at the number in standard form. So they actually figured out on their own that they could go back and say, hey, this number's in standard form would be this, and this would actually what it would be in scientific notation. So they figured out that when they had the, and when the number was less than one, because a lot of them told me when the number was less than one, the coefficient, the exponent would be negative, and when it was greater than one, the exponent would be positive as they moved it. So they figured it out on their own, which was, was pretty a pretty deep process for that type of learning, because that's not an easy concept to master, to figure out when to adjust and whether I need to add or subtract an exponent.